All right, in this video we're going to talk about completing the square as a method of solving quadratics. It's a really important technique. It's a powerful technique that can be used on any quadratic equation. It is also the method through which we get the quadratic formula. Here's just a quick lecture on how to go about doing this. First and foremost, you have to have this in your toolbox. You have to know how to solve quickly equations that look like this. These are special forms of quadratics that where this left-hand side is completely factored, and we'll get more into that. The way you solve these is just by applying the square root to both sides of this equation. The square root will cancel out the square on the left-hand side, and what you get left with is x minus 4 equals plus or minus 5. And then these can be solved by setting these to solving these two separate equations. X minus 4 equals 5 and x minus 4 equals negative 5. So that's the first thing. The second thing to know about is perfect square trinomials, and I'll just give a couple examples right here. Let's say x plus 5 squared, and then I'll do x minus 4 squared. The important thing about these is that when you expand these out, and just again a quick reminder of x plus 5 squared is x plus 5 times x plus 5. What you get when you multiply all that out would be x squared plus 10x plus 25. In the second example, what I would get, and I won't write it all out, but you get it, it's x minus 4 times x minus 4, and what I get as a result is x squared minus 8x plus 16. The key here is looking at these coefficients and the results of these perfect squares. Perfect square trinomials are the result of squaring a binomial, and they always have this feature where the b term, or the middle or linear term, is always twice the value of what's being added or subtracted on to x here, and then that'd be the 10. So we have a positive 5 times 2 is a plus 10, and then this last term is just that 5 squared. It's just verify with this second example, right? When I take x minus 4 and square it, what I get is negative 8, which is 2 times the negative 4, and then I get this 16 on the end, which is negative 4 squared. In general, perfect square trinomials have this form. If we have x plus or minus a, we'll consider a to be any integer, and it works. This will generalize. You're always going to get x squared plus 2a plus a squared. Again, this term right here, by the way, will be negative, as it was in this second example, if that a value is a negative number. So I would think of a as negative 4. That's why I get 2 times negative 4 would be a negative 8 right here. All right, let's get to it. Here's how we solve by completing the square. First move, I'm always going to just move over this c term to the other side. I do that by subtracting 16 to both sides. What I'll get is x squared plus 10x equals negative 16. Then what I'm going to do is I'm going to create a perfect square trinomial on this side right here. Again, the perfect square trinomial had this middle term was 2 times this value, or that a, and then this last constant term was that number squared. So the game looks like this. I'm going to take this 10, I'll do it on the side, and I'm going to divide it by 2 to get 5. Then I'm going to take that number 5. 5 is really important. That's this a term. I'm going to take that 5. I'm going to square it to get my constant that I want of 25. So what I'm going to do with that is I'm going to add 25 to both sides of this equation. So I'm not setting it equal to 0. This is kind of the strange thing about this, is I'm not setting it equal to 0. What instead I'm doing is I'm trying to create a perfect square trinomial on this left-hand side, and you'll see in a second why I would go about doing that. And I'm going to get 9 on this right-hand side. Now I know, because of the way I've set up these coefficients, and you'll have seen from the previous example that I did, x squared plus 10x plus 25 will factor into x plus 5 times x plus 5 when I factor it. I don't have to think about that though, because of the way I constructed this. I know it's x plus 5 squared equals 9. Again, this is x plus 5 times x plus 5 is what this is right here. The beauty of all of this, if you can see what we've just done, we've now taken this quadratic in this form, which is really a general form of set equal to 0. We put it into this form, which actually is the easiest way to solve this now is by using the square root. And so I get this, and I'm going to take the square root of both sides to get x plus 5 equals plus or minus 3. Then I'll solve these two equations. X plus 5 equals 3, and x plus 5 equals negative 3, giving me the two solutions of x equals negative 2 and x equals negative 8. Again, just in quick review, what we do is we don't want it set equal to 0 like normal. What we're going to do is first just isolate these first two terms, the quadratic and linear terms of the left-hand side. We're going to add our special constant on. That special constant is found by taking half of this b value, or 5 in this case, and squaring it to get 25. If we do that, we're going to create this perfect square trinomial on the left-hand side. Yes, we don't have this side equal to 0, but that's not necessary, and in fact, almost never going to be the case. We then factor that into this form, x plus 5 times x plus 5, or x plus 5 squared. And then we solve this equation by taking the square root of both sides of the equation. Let's look at one last, a little bit more difficult example. All right, to solve this equation, we have one extra little move to do. The difference with this problem is that we have this lead coefficient that's not a 1. And if you've been following along with quadratics, this always makes things a little bit more difficult. Actually, the move is not too complicated in this case. We need this lead coefficient to be 1 to implement the idea of completing the square. And so what we simply need to do is we're going to divide everything by 5, which we can always do in an equation. So I'm going to divide each term of this equation by 5. That will result in this equation of x squared minus 14x plus 48. That's really just the new trick. Everything after it is exactly the same as what I did before, but I'll show those moves here real quick. I'm going to take half of negative 14 to get negative 7. That's my a value I need. Negative 7 squared is 49. By the way, this will always be positive that I'm going to add on. I'm going to add 49 to both sides of this equation, and I'll just show that quickly here. If I add 49 here, what I get is x squared minus 14x plus 49. And then over here, if I got negative 48, I add 49, I'm just going to end up with a 1. Now, this next step is the most important, is knowing what the heck did I just do there, and so we'll just do this. The x squared minus 14x plus 49, this factors into x minus 7. That minus 7 is always this number right here that I got when I divided that b value by 2. So half of negative 14 is negative 7, so x minus 7 squared equals 1. Now I solve with the square root, apply the square root to both sides of this equation. Oops, you get the idea. And I get x minus 7. Again, the square root cancels out the square. And then over here, the square root of 1 is 1, and I always get this plus or minus when I take the square root. And then these two equations can be solved. X minus 7 equals 1, x minus 7 equals negative 1, resulting in x equals 8 and x equals 6 are my two solutions to this equation. Last thoughts on this. To complete the square, you don't set it equal to 0. What you're trying to do is to create a perfect square trinomial on one side. The way that I do that is I set the x squared term and the x term on one side. I figure out what constant I want, and then I add that to both sides after I've already moved that constant to the other side. Then I factor the perfect square trinomial in a perfect nice way. In this case, x minus 7 squared. In the previous case, it was x plus 5 squared. Then I use the square root to solve, which feels a little bit weird at first, but as long as you remember this plus or minus to get the two solutions, it's really the fastest, easiest way of solving a quadratic. Well, sometimes this is going to seem for some problems like a drawn out process. Why would you ever do this? Factoring maybe is easier and faster. The real beauty of this is while factoring is limited to problems that have been baked to work for factoring, this method will work for absolutely every equation that you see, whether it has nice integer solutions, whether it has fractional solutions or rational, or even if it has irrational up to imaginary or complex solutions. This method will work for all of those, and that is why it is worth your time.